All right, welcome back once again. So let's actually go through our PowerPoint. This PowerPoint is available on our Moodle site. So while I'm discussing this in this lecture, I want you to follow along in your PowerPoint as well when you're at home or when you are taking an online class. So I'm actually on slide number 4. The slide number 4 provides a very brief definition of stack. What is a stack? According to your book, a data structure in which elements are added and removed from one end only. So consider stack of plates, stack of books, and we'll see some of those analogies. Addition and deletion occur only at the top of the stack. So if you want to remove something from the stack of the book, you're going to remove the top from the top of the stack, not from the middle, not from the bottom, from the top of the stack. Last in, first out, LIFO data structure concept is applied here. There are various types of concepts we use in computer science, LIFO, FIFO, GIGO. There are so many different concepts. Here in stacks, we'll use last in, first out. So last book which was stacked will be the first one to be removed. So LIFO concept is applied here. So some of the concepts you'll hear in stack discussion is push and pop. So to add an element, we call it a push. So when you want to add something to the stack, you basically use push method. When you want to remove something from the stack, you use a pop method to remove an element from the stack. Okay? So these are some of the terms we'll be using. There are some stacks here. So stacks of books. Stacks of books. This is on slide number 5. So if I want to remove one of the books, so I can remove only because based on LIFO methodology. Last in, first out. Stacks of boxes, stacks of trays, stacks of coins, and so on and so forth. Here's my empty stack. I do not have anything in this empty stack, assuming we have some of these pieces of data. We have A, B, C, D. These are the pieces of data. How do I stack them? How do I add them to my stack? So I can push box A, and then I can push box B on top of box A. I can push box C on top of box B. Then I can peek at the top element. I can see how many elements have been added to my stack. I can also push box D. So box D is added to top of box C. And I can pop box D. Pop means remove. So this is exactly how we are going to use our program, how to add or remove something. Some of the key methods we must have in stack at the time of declaration of stack, and these must be implemented, such as initialize stack, check if the stack is empty, check if the stack is full. And you must have push, pop methods to add something or to remove something. And also there must be a method which allows you to check what is the top value. Top value means how many elements were added, or if I want to see the value of that last node in that stack. So first element goes in first array position, second in the second position, and so on and so forth. Top of the stack is index of the last element added. So if you're aware, when you're using array concept, so you start with the 0th index, and I'll show you that in a few minutes as well on the board. So 0th index, so if you have, let's say, a stack of 50 items, so you will go through 0 to 49. So it's saying here, top of the stack is index of the last element. Index of the last element. Now stack elements are stored in an array, which is a random access data structure. So this will be much easier. In fact, this chapter 17 talks about how to create a stack by using an array concept as well as using linked list nodes. To track the top position, use a variable called stack top. So we just want to verify, ensure that we know where exactly the top of the stack ends, or what is the last value we added. So if you have declared an array of 50 or 100, and that doesn't mean that you have 100 values. It means that you might have only 3 or 4 values. So only the 4 elements were added to the stack. So that stack top variable allows you to verify where your stack top is. Now, the concept implementation of stacks as arrays allows you to dynamically allocate arrays or dynamically allocate these values. Enable users to specify size of the array. Now, if you remember when we talked about arrays last week as well, 2 weeks ago, we said that there are some issues with arrays. Arrays are fixed number of sizes. We have to initialize at the time of the declaration of the array, or we have to tell the program that I intend to use only 50 or 100. But there's another concept called dynamic arrays. Dynamic arrays are called vectors. These can be expanded during the execution of the time of the program. So you can actually expand the size of your array. So let's say you start with 100 elements, and during the execution you realize you need to add more data. You can actually expand the size of your array. And that's called dynamic array. That's what it's highlighting here. It can dynamically allocate array. So you can specify the size, and then you can expand the size of your array as well. Class stack type implements the functions of the abstract data type. So this is my abstract data type, which was discussed earlier on, the virtual methods. So, and that's called ADT, abstract data type. So we would be implementing those methods here. Again, this is a review from 2 weeks ago. So C++ arrays begin with 0th index, must distinguish between value of the stack top and array position indicated by stack top. Now, stack top might say size 4, or stack top is 4, which means 4 elements are added. But the array element or array index might be 3, because arrays begin with 0. 0, 1, 2, and 3. So when we talk about 4 elements, the array index might be 3. So we just need to be careful as a developer, understand between those two concepts here. If stack top is 0, stack is empty. It means none of the elements were added. If stack top is non-zero, it means stack top is not empty. So if I want to check if my stack is empty or not, I can just check. If the stack top is greater than 0, then it means it's not empty. At least there is one element in that stack. All right, this is what I have on the board as well. So for example, if we declared an array of 100 elements and we would like to convert this into a stack. So assuming these are the values, A, B, C, and D, these are the values we added. So the maximum stack size in this case is 100, but the stack top is 4, because there are 4 elements in that array. And the list is the pointer. List is the pointer which is going to allow me to traverse this stack or this array. So that's where I'm pointing. By pointing here, I know what the size is. So I can actually use a very simple for loop to go through this entire stack. If I want to manipulate the data or if I want to simply print the data. So notice that these are the indices or index or subscript. So subscript 0 means the first element. Subscript 3 means the 4th element. Subscript 99 means the 100th element. I'm going to move on. It's just showing you if the stack top is 0. And then it talks about what these methods look like. And I'll be showing you these methods a little bit later as well. So let's just focus on this name here. And don't worry too much about how this is implemented. It's just showing you the header file is separate than the implementation file. So we'll do that together, that we can separate the header and CPP file. So if the header and CPP files are separate, you have to use the scope resolution operator just to show the body of that method. So here, this is the method isEmptyStack, and I'm checking right there, stack top equals 0. If this condition is true, if the stack top is equal to 0, return true. And notice that it returns a Boolean variable or Boolean type of data. So if this one actually is true, it will be telling us that yes, the stack is empty. If the value is non-zero, any other value is being returned, it means it's actually it has some data. So this will determine, and this one-liner method will allow us to understand if there's data in the stack or there's no data in the stack. And that's exactly how we are going to have in our program, and even in the future programs. And this will relate to our queues next week as well. So if you understand how you can check the value is there or not, you can really check very, very quickly. Can I use a separate if, like this I stated last week as well? Can I use a separate if condition, if stack top equals 0, then return true or false? Absolutely. But this is a quick way to do it. In just one line, both of those conditions can be met. If I want to check if the stack is full, which means assuming we have maximum size 100, assume that, and if my stack top is equal to maximum size is 100. If my stack top is 100, it means there's nothing else, there's no more space left. The stack is completely full. I cannot add additional shoe boxes in the bigger box. I cannot add additional books in my backpack. It's completely full. So that's exactly if the stack is full or not. We can check stack top equals maximum stack size. Again, it's going to return some kind of true or false value. Once it returns true, it means it is full. Really, really simple methods. And this is kind of relates to our discussion from last week as well. Now, how do we add or remove something? I want to push something into my stack. I want to add something to my stack. So we use a method called push. So push method stores the new item in the array component and increments the stack top. So initially, if the stack top is 4, I want to push another element on top of the stack. I'll increment the stack top to 5 because I want to keep track how many elements are in the stack. And is it possible overflow can occur? Let's say I'm actually on the top of my stack, maximum stack size. If I try to add another item, do you think the overflow can occur? So how do you avoid an overflow? How do you ensure that you're not going beyond the limitation you have set for yourself in your code? Is that a good practice that you want to add additional items? Initially, you were estimating that there'll be only 100 items. Now you are expecting maybe more than 100 items will be added. So what do you do in that case? Do you stop and say, I cannot add more data? Or do you expand the size of your array? What would be the practice? So you can expand, or based on your company's requirement, based on your client, you might say, you know what, that's the maximum I can handle. So you can actually go both ways. So here it says overflow occurs if we try to add a new item to a full stack. So I would actually be on the safe side. I will actually probably expand the size of my array. So, or you can simply say, you know what, my stack is completely full. I cannot add more items to the stack. What about the top? I want to check what's the top value. Top value means what is on the top of the stack. I want to see what value resides there. So this top method, which will look like this, all I'm saying is stack top -1, show me the value of that list, of that node, or that array. Show me the value of that array. Why stack top -1? Why stack top -1? If stack top is 4, why do I need to say -1?
Index is
That's right. It's because array size will be, array element or array subscript will be 3. 3 means 4. Now, don't say that I'm just talking nonsense, because arrays begin with 0th index. So 0, 1, 2, 3. So 4th element, stack top is 4. That's actually basically array size or array index 3. That's why you're subtracting -1. Here you're checking if it's not equal to 0. You're checking if stack top is not equal to 0. It has some data. Then continue. Otherwise, if the stack is empty, terminate the program. So this assert function, if the value is equal to 0, then it's going to stop. It says, well, I have nothing to return back to you. I don't have any top value because array size is equal to 0. So this will be displaying the data. This list value will be returned as type. And you say, I still don't understand what type is. Well, type is, we declared a class of type as a template. What it means is any kind of data. And that's exactly what we did in assignment 1, any kind of data. Because it's a template, so it could be an integer, it could be a string, it could be any kind of data. And that's what we are saying here. Whatever the array index is, return this array index of type. If you want to be more specific, understand as integers or characters or strings. Whatever the type of data which was stored in the stack, that type of data will be returned as a template. Okay, so that's your top method. And to remove something from the stack, decrement stack top by 1. So if your stack top is 4, you say, I'm going to remove one element from the stack. So stack top becomes 4 minus 1, which is 3. So underflow condition, trying to remove an item from empty stack, that would be a dangerous thing to do. So you want to have a check on that one. And here is my pop method. I'm checking if not is empty stack. If the stack is not empty. If it's not empty, that's the condition I'm checking, just to avoid any underflow. Just to avoid that I'm not trying to remove something from the empty stack. If that's the case, stack top minus minus. If that's not the case, then simply say cannot remove from an empty stack. Just a message for the user. So user knows or the developer knows that there's no data in the stack. So you saw the top method, you saw the pop method, really simple methods. You saw that how we can actually check these things in 1 or 2 lines of code. Okay, so I'm going to skip that one. And then we'll talk about copy stack. In fact, I'm going to talk about copy stack when we get to the program itself. So far so good. So we are currently on slide number 23. So if you look at the PowerPoint, the first 50, 60 slides relates to stack. So this PowerPoint is a very large PowerPoint. It has more than 100 slides. So half of the slides, they talk about stacks, and the rest of the slides will talk about queues. So I'm not going to go over all of the slides. I'll be discussing some of the slides with you this week as well as the following weeks as well. Okay, let's take a break.